In this tutorial, we're connecting a DHT11 temperature and humidity sensor to an ESP32 Rover E development board using the Freenov GPIO extension. We'll wire everything on a breadboard and display live temperature readings on an LCD screen. Let's start with the pull-up resistor. We're placing a 10 kΩ resistor right here on the breadboard. This resistor ensures stable and reliable communication between the sensor and our microcontroller. Next, we need to establish our ground connection. Take a jumper wire and connect it from this position on the breadboard to the ground rail on the extension board. This creates our common ground reference point that all components will share. Ground connections are essential for any circuit to function properly. Now we're wiring the data line. This wire bridges the connection across the breadboard like this. This line will carry the digital signal containing our temperature and humidity measurements. Here's where we connect the sensor signal wire to the ESP32. We're routing this to GPIO 18, which is one of the digital input pins on the Rover module. The ESP32 will read the sensor data through this pin using a special one-wire protocol. For power, we're connecting from the positive rail to the sensor. The DHT11 operates on 3.3 volts, which comes from the extension board's regulated output. This provides clean, stable power to keep our sensor running accurately. Now let's place the DHT11 sensor itself onto the breadboard. The sensor has 4 pins, and we're positioning it to span across these rows, so each pin sits in its own connection point. Make sure it's firmly seated in the breadboard. Time to add our LCD display. First connection is ground. We're running this wire from the LCD's ground pin to the ground rail on the extension board. Every component needs a ground connection to complete the circuit. The LCD needs power, so we connect its VCC pin to the 5-volt rail. Unlike the DHT11, this particular LCD display runs on 5 volts rather than 3.3. Now for the communication lines. The LCD uses Y2C protocol, which requires 2 wires. We're connecting SDA, the data line, to GPIO 13. Then SCK, the clock line, goes to GPIO 14. These 2 pins work together to send display data from the ESP32 to the LCD screen. To make our circuit cleaner and easier to troubleshoot, let's replace these jumper wires with color-coded ones. Using consistent colors like red for power, black for ground, and other colors for signals makes debugging much easier down the road. With all our hardware connections complete, we're ready to program the ESP32. Opening Thorny IDE will paste in our Python code and run it. The code initializes the DHT11 sensor and the I2C LCD display, then continuously reads temperature and humidity data. And there we go! The sensor is reading 21 degrees Celsius, and as you can see, that exact same reading is now displaying on our physical LCD screen in real time. The ESP32 is successfully reading environmental data and updating the display. Project complete.